Hello, this is Teacher Peter. In this video I will look at topic 2 of year 10, indices and surds. This is part 1, and in this part 1 I will look at surds. Now before we proceed, let's look at these two terms, rational and irrational numbers. What are they? Rational numbers. A rational number is any number that can be located on a number line. That means that number can be located on a number line. So if that is a number line, so that number can go up to, let's say, infinity, negative, infinity, and so forth. A whole number. So we are talking about a whole number. Number 2, a rational number, is a number that can be written in form of x over y, where x and y are integers. But remember that y, which is the denominator, must not be equal to 0, because whenever a number is equal to 0, that means the solution will be undefined. So y and x must be an integer, but that integer, when dealing with denominator, must not be equal to 0. So we have examples of rational numbers. These are whole numbers. Then the second one are fractions. Any fraction is a rational number. Then we have number 3 is the terminating. This is repeating decimals, or another name for repeating decimal is what we call recurring decimals. And terminating decimal. Terminating decimal is a decimal that has an end. For example of a terminating decimal is this one here, 0.75, and if you can convert this one into fraction, then you will get 3 over 4. Now for repeating or a recurring decimal, then we have an example here of a fraction which is 4 over 3. This fraction will give us a recurring decimal which is 1.3, and 3 is recurring. 3 is repeating itself, so we have a dot at the top there. So all these are what we call rational numbers. Now what are irrational numbers? An irrational number is a number that cannot be represented or expressed in the form x over y. So cannot be put as a fraction, where x and y are integers. This number have non-repeating or non-recurring decimal. They are non-terminating decimal expansions. So they are non-terminating is a decimal that won't end, so meaning that we cannot have a fraction for that decimal. So examples of irrational number are the square root of non-perfect square. So for example, a square root of 2, square root of 3, square root of 5. So when we talk about square root of 4 is a perfect, has a perfect square, and therefore is will end up giving us rational number. But any number that does not have a perfect square, or is not a perfect square, then will give us an irrational number. Then we have another example of pi. Now And that's how now the irrational number are obtained. Now, when we talk about irrational numbers, most of the case surds are there, are examples of irrational numbers, and in this video we will be talking about surds. Now let us see some very good examples here, and we will start by addition, adding and subtraction, whereby for us to be able to add a surd and to be able to subtract a surd, then there is something that we should be able to understand. Number one, we are adding the surd, so we must have this aspect of simplification. So we must be able to simplify a surd. For example, we have these two surds. One thing that we should know, for us to be able to add or subtract, then anything that is inside the surd must be the same. Example, we may have 4 root x plus 3 root x. This one is doable because whatever is inside the root is the same. So here, adding, we consider adding the coefficient, which are 4 plus 3 is 7, so it will be 7, then root x will be the answer. Now let's see our question here. The question is 5 root 2 plus root 8. Okay, now this root 8 here, we can simplify it so that we may have root 2. So how are we supposed to simplify it? Now this is what we will get. This is 5 root 2 plus root 8 can be written as root 4 multiplied by root 2. Now it's getting simpler because root 4 is a perfect square, so root 4 will be just 2. So therefore we are getting 5 root 2 plus 2 root 2. So already this root 4 is 2. So therefore now, after getting the same number inside a root, then we can be able to add. Adding, we add the coefficients, the first coefficient of the first one and the coefficient of the second one. So 5 plus 2 is 7, then this is 7 root 2, and this becomes the answer. That becomes the answer. Now let's now go to the second one. In the second one, we will use another concept. Here we have simplified, but now the concept in the second one, we can also simplify, or we can express now a surd as a square root of a positive integer, meaning that in the first number here, which is 3 root 2, we can make sure that everything is inside the root. How do we do that? So there is a rule that normally tells us that root x squared is equal to x. So root x squared is just equal to x. So therefore, if root x squared is equal to x, then we can say in our term, first term here, we can say that root 3 squared is equal to 3. Is equal to 3. So therefore, we can substitute 3 with root 3 squared. So we can substitute it and say root 3 squared multiplied by root 2 plus 5 root 18. So therefore, let's see. So we can combine these two. Already root 3 squared is just root 9 multiplied by 2 plus 5 root 18. So multiplying 9 by 2, we are getting 18. That is root 18 plus 5 root 18. Now adding is very simple because everything now inside the root are the same. So consider adding the coefficient here. Coefficient of the first is 1. So 1 plus 5 is 6. 6 root 18. So that one becomes the answer. Now look here, we have addition of surds. Whenever you are adding surds, remember that there is a condition that tells us that you must add those factors that are the same. If this is m x root x, then the other one will be n root x. So this one you can be able to add, and the answer there will be m plus n then root x. That will be the answer. You can only add if whatever is inside the root are the same. Now for you to make sure that everything that is inside the root is the same, then you have to ensure that you either simplify or you express the surd that you have been given as a square root of a positive integer. Now here is a question asking us to prove that the following surds cannot be added or subtracted. So meaning we have here are the signs there. We have either additional or subtraction. So prove that these two surds cannot be added or subtracted. So therefore the question requires us to prove that in the first surd what is inside the x, and in the second inside the root, and in the second surd what is inside the root will not be the same. So therefore we need to simplify. We need to simplify both of them. So simplifying the first surd, which is 2 root 200, simplifying it, then this one will be 2 root 200 can be written as 100 multiplied by 2, but this is just 2 root what 10 squared multiplied by 2. So already we can now we have a perfect square here, which is 100 is a perfect square. Finding the square root, getting the square root of it, then we are getting 10. So we can now remove it now from the square root sign, and then 10 multiplied by 2 will be 20. So 20 root 2, that is the first term. The second term is 3 root 300. Okay, now using the same idea, so we are getting this is 3 multiplied by root 100 multiplied by root 3, and this one can be 3 root 10 squared multiplied by by 3. So finding the square root of this, then we are getting 10. So 10 multiplied by 3, this is 30 multiplied by root 3. So 30 root 3. Now, meaning that our expression here will be equal to 20 root 2 plus or minus 30 root 3. Now, it is evident that whatever is inside the root in the first term and the second term are different. So here we have 3, 2, here we have 3, and therefore the two terms cannot be added or subtracted. So already we have proved. So proving requires you to simplify, and then once you have simplified them fully, then compare. If or just look at the term that is inside the root. If those terms are different, then the additional adding or subtraction cannot be done. But remember, when we come to division and multiplication, according to the rules of according to the common rules that we have for Surds, we can multiply the terms even having those terms having different numbers or different figures inside the root. Now let's proceed. In the next concept is about multiplication and division of Surds. Now this is question number 4. Simplify the following question. So part A, this one is very simple because we have a row, and the row here says that whenever you have root x multiplied by root y, then this is just x multiplied by y inside one the same root, inside the same root, and finally you will have root x xy. Therefore, for this question here, then root 3 multiplied by root 5 will be equal to root 3 multiplied by 5, which is just equal to 5 multiplied by 3 is 15. So root 15. That becomes the answer. Now for division, is something that looks the same but somehow different here now, because we are dividing. Now dividing, this means that this is root 26 divide by root 2. Now there is something that we already know here, that root 26 is just equal to root 13 multiplied by 2. Root 13 multiplied by 2, then over root 2. So this one can be written as root 13 multiplied by root 2 over root 2. So root 2 and root 2 can cancel, and then we are getting the answer to be root 13. I think division and multiplication are somehow simpler than additional and subtraction, because in addition and subtraction you need to consider what we call simplification, and sometimes you have to express a surd as a square root over positive integer for you to be able to do all those operations. Now let's proceed. The other concept is on the binomial product, and in 2D binomial product of surds, we will look at the distributive row. For example, if you have two surds that you are supposed to multiply. That is a plus b into bracket, then multiply by c plus d. Then using the distributive row, you will multiply a multiplied by c. You multiply a multiplied by c, and then plus a multiplied by d, and then you go to now to b multiplied by c, then plus b multiplied by d, and the answer you get that answer there. Now whenever you are supposed to expand a perfect square, whenever you are told to expand a perfect square, that a plus b squared, now here is where now we normally use a binomial product. You use the coefficient, the binomial coefficient, or 2D binomial coefficient, which is just 1, then 2, then 1 at the end. But remember, the first term is always a squared, so the coefficient of a squared will be 1, so this will be a squared, plus the coefficient of the second term will be 2, so the second term is normally a product of the first term and the second term, which is a multiplied by b, and this will be ab. And then finally the coefficient of the last term, which will be as b squared, or the second term squared, will be 1, so we are having b squared. So that is how we get the product very easily. If then we have a negative here, we have a negative, that is a minus b squared, then we still have the same coefficient, 1, 2, 1, and we still have the same terms. We have a squared, then ab and b squared, but the sign changes. The first sign here will be minus, and the other one will be plus. Now that's how to get them. Now when it comes now to the real thing of multiplication, let's see the first one. Here you just use the distributive row. You multiply 4 will be multiplied by the root 3 minus 2, and then plus this one here, root 3 multiplied by root 3 minus 2. So then removing the bracket and then combining the right terms together, we get this will be 4 root 3 minus, then 4 multiplied by minus 2, that is minus 8, then plus root 3 multiplied by root 3, that is root 3 squared, that is 3, then we have minus, plus multiplied by minus, then root 3 multiplied by minus 2, that would be 2 root 3. Now correcting the right terms together, that means we have 4 root 3 minus 2 root 3, then minus 8 plus 3, and now this gives us 4 root 3 minus 5. That is the answer. That is the answer for that question. Remember, you are supposed to expand and then simplify. Simplification, after expanding, then simplification is correcting the right terms together, adding them, or using the body mass, the operator that is suitable for them to be done properly. Now in the next question, part B, we have a perfect square, but remember now perfect square here, this one is like a plus b, and a plus b will always give us a squared plus 2ab plus c squared. Now it's very simple here, because now you will square the first term here. Squaring the first term, which is 2, you get 4, then plus the next term will be the product of the 2 multiplied by 2. The product of the 2 is 2 multiplied by root 7, that is 2 root 7, then multiply by 2 will be 4 root 7, and then the last term will be the second term squared, so that is root 7 squared. Root 7 squared is just root 7 squared, so therefore the final answer becomes 4 minus 4 root 7. Root 7 squared is just 7, so this is plus, so therefore if you add, you get 11. Collect the right terms together, you get 11, then plus 4 root 7. That becomes the answer. Now the final part in Surds is all about rationalizing the denominator. So simplification by rationalizing the denominator. So what is rationalizing the denominator? This is a process of removing a surd from denominator by converting the denominator from irrational number to a rational number. For example, as you can see the first one here, rationalizing means that you multiply the denominator by itself whenever you are given one term. Like in the first question in part A, we have been given a denominator as root 3, so we are supposed to multiply root 3 by root 3. But remember, a factor that we will multiply with must be root 3 over root 3. So what you do in the denominator, do it in the numerator. That was a law of Moses that dictated that if you, what you do to your friend then should be done to you also. So if you slap your neighbor, then you are supposed also to be slapped with the same strength. So therefore, whatever you do on the denominator, proceed and do it on the numerator. Multiply by that number. So this means that it's as if we haven't done anything, because if you can cancel them at this particular place, you will find that this is root 3 by root 3 by, you are getting just 1. It's like we haven't done anything. So we are not cancelling, but we will just multiply. Okay. Now multiplying everything now here by numerator here, then you will get root 3 multiplied by 3a minus root 3, and then this will be root 3 squared. So we will get something of this nature. We'll get root a, that is 3a root 3 minus root 3 squared is just 3, or root 3 multiplied by root 3 is just 3, then over root 3 squared is just 3. Factor out 3 at the numerator, so you are getting 3 into a root 3 minus 1 over 3. Divide by 3, divide by 3, and the final answer is a root 3 minus 1. That is the answer. Now to the second one, part B. Part B is about technical, but not that much, because when rationalizing a denominator having two terms, you multiply by a number that has a different sign. So those surds will have a different sign. Now, like now, what you can see here, this is will be root 4 plus root 3. That's what you multiply with. But remember what we said, whatever you multiply with denominator, remember to multiply with it to the numerator. So that is the rule whenever you are rationalizing the denominator. So, and for this matter, there is a concept that we already know. Anything we have a squared minus b squared, this one will always be equal to a plus b, a minus b. So this one, the denominator, what you are getting here, is just equal to root 4 squared minus root 3 squared, without even doing much mathematics. That is the concept. Now denominator, multiplying the denominator will be, that is root 2 multiplied by 8 multiplied by root 3 multiplied by 2. That's what we have. So we are getting root, this is 4, sorry. So we are getting root 8 multiplied by root 6 over root 4 squared is just 4 minus root 3 squared is just 3. So we are getting what? We are getting root 8. Root 8 will be equal to root 4 multiplied by root 2. Then are we multiplying or adding? This is addition, plus root 6 over, this is just 1 if you minus. So the reason as to why I separated them like this, because root 4 is a perfect square, so you'll be getting the answer there will be 2 root 2 plus root 6. That becomes the answer. Now by that, now I hope you know how to add surds. You must simplify them for you to be able to add them. I'll minus. Number 2, you know what rational and irrational numbers are. Number 3 is that you already know how to multiply and divide surds. Then the other thing is about how to expand surds. You already know how to expand surd. And finally, you already know how to rationalize the denominator. Thank you very much for being with me. So hope you enjoyed the video. Thank you very much.